Hello guys, welcome back to my channel. Today is the day 13 of our computer vision series. The link of the playlist is in the description below, so make sure to check out the entire playlist. Today we're going to see how we can make a simple face detector using just a few lines of code. So first we're going to see how it can detect the faces on an image, and then we're going to see the real-time face detection using a webcam as well. But as you can see from the length of the video, we are not going to create this model from scratch. We are going to use a pre-trained model to detect the faces for us, because when life gives you a lemon, don't just make lemonade out of it, but you can just sell it for more profit. So let me first show you what we're trying to achieve, and then we can go on to our VS Code. Well, I'm already on my VS Code, but then we can go and create our own face detector from scratch. So I have prepared a few images, and as you can see, this face detector is perfectly detecting the faces, and some of the faces that it might not be able to detect is maybe because of the lightning, or maybe because of the distance, or maybe because of the noise that we have. And as you can see, it is detecting the faces pretty well. So this is what we are trying to achieve in our today's lecture. So let's get started. But before starting to code it, let's first discuss the pre-trained model that we are going to use. So OpenCV provides you with a lot of pre-trained models that you can use for detecting different things, like for detecting an eye, for detecting the face of a cat, for detecting the lower body, the right eye, the smile, and so much more. So you can just think of it as a machine learning based approach for object detection. Okay, and OpenCV is providing you with a lot of XML files of the pre-trained models that you can use. Since we are trying to create a model for face detection, the one that I'm going to use is Haar Cascade frontal face, which must be somewhere over here. So this is the one that I'm about to use, Haar Cascade frontal face default. You can also use the profile face if you want to detect some side faces as well, but since I want to detect the frontal face only, so that is why I'm going to use this one. So I'm going to click on this one, and then I am going to see that this is the XML file, and I will download the raw file by clicking over here. Once it is downloaded, make sure to move your file into the same directory where you are about to code. Since I am about to code in my day 13 directory, so I have pasted my XML file right over here. And this is the group.jpg image on which I'm going to detect my faces, because first I will use the face detector on an image, and then I'm going to modify the same code to use it on a webcam. So let's start writing the code. So the first thing that I'm going to do is to import my OS library as well as my OpenCV library. I'm not going to use any other library for this project. We only need these two libraries. So the first thing that I'm going to do after this is to load my classifier. This is my classifier over here. I have to load this XML file into my project. So that is what I'm going to do. I'm going to call it as face cascade, and I'm going to use Cascade Classifier, and over here I'll write the name of the file. Now in the meantime, while I write the file, I'll tell you one thing, that all of the models that we just saw in the GitHub repository, they are actually trained on the Haar feature based Cascade Classifier algorithm. Okay, so once you know how to use one of these pre-trained models, you can modify the same code and it will work for all the other models as well. So I have successfully loaded my model into my file. Now I'll see how I can detect the faces on an image. So the first thing that I have to do is to read the image. So that is exactly what I'm going to do. First, I'll define my image path. Since my image is in the same directory as my file, so I'm going to define its path. It's going to be day 13, and the name of my image is group.jpg. Okay, and then I'll read the image using my imread function, and I'm going to pass the path over here. Now to see if it has successfully read the image or not, I'm going to visualize my image as well. So let's do that quickly. And then finally my wait key function. Okay, now let's run it and see if it's running correctly. Okay, yes, so it has successfully visualized the image for us. I'm gonna close it, and now we will see how we can detect the faces, how we can use this classifier that we just loaded. Okay, so this classifier works best on the grayscale images, right? So first we are going to convert our BGR image, because by default all our images are in BGR, right? So we are going to convert it from the BGR color space to the gray color space. So I'm going to call that as gray. I'm going to use OpenCV function, which is called as CVT color, and over here I'm going to pass my original image. Then I will say color BGR to gray. Now I've successfully converted my image from BGR to gray. Now I'm going to call a function. I'm going to use face cascade dot detect multi-scale. Now this will detect the faces for me, right? So this is going to return faces to me. I'm going to tell you what faces are in just a second. So I will save it in a variable called as faces. Now over here I'll pass my grayscale image, because it only accepts a grayscale image. It works best on a grayscale image. That is why we had converted it. And over here I'll pass a scale factor. You can think of scale factor as something like, it's gonna uh, the higher the value of the scale factor, the faster it's going to be, but the less accurate it's going to be. Okay, so the greater the value of my scale factor, it's going to detect the faces faster, but it might not be that accurate. It might miss some of the faces as well. But the smaller the value, it might be a bit slower if the value is small, but it's going to detect the faces more accurately. So how to figure out what this value is going to be is through trial and error. I myself tried different values while I was creating this project, while I was testing this out, and this value worked best for my images and my webcam. That is why I chose this image. And usually the value lies between 1.1 or 1.05 to 1.4. Okay, so you can try any value between this. Okay, so now I have to tell the minimum neighbors. So I'm going to write 4 over here. Now how does this minimum neighbors thing work? This means that if I have at least 4 rectangles or 4 bounding box or 4 detections that are overlapping each other, only then it is going to call that as a face. Okay, so you can write a bigger value over here as well, you can write a smaller value over here as well, but the thing is that if you write a very big value over here, then it's gonna give you a very accurate result. It's gonna have a few detections, but it's gonna give you a very accurate result. And if you write a smaller value over here, then it might not be that accurate, and but it's going to have more detections. It's going to detect more faces, and it's even going to detect some of the faces that might not even be faces. So it totally depends on what you want to choose. Usually the values lie between 3 and 6, but it's totally up to you. You can choose this value through trial and error as well. Okay, so this function will return faces to me. Okay, now faces over here is a Python list, and each element of this Python list are the coordinates of the bounding box of a face. So you can say that each element is basically the coordinates of my face, right? So let's iterate over this list. Since this is a list, I can obviously iterate over it. So it's going to return 4 coordinates to me, right? X and Y are the coordinates of my top left corner of my bounding box, and then the width of my bounding box, and then the height of my bounding box. And since we are going to iterate over this faces list, so I'm going to say in faces, and then we are going to just draw the bounding box. We have the coordinates. We are just going to use the rectangle function of the OpenCV to draw the coordinates. So first I'm going to pass the image. Since I want to draw it on my original image, I'm going to pass my image over here, and then I will tell 2 positions to it. The first one is the top left corner, which is going to be x comma y, and the second one is going to be the bottom right corner, which is x plus width and y plus height. Okay, then I have to tell the color to it. I'm going to create green bounding boxes, so I'm going to pass 0 to 55 and 0 because it's BGR, and then I have to tell the thickness, so I'm going to pass 2 as the thickness of it. Okay, and now I think the code is complete and this should hopefully work. Let's see. Okay, so it gave me an error, and the problem was over here. I have to write the path of my XML file over here, right? Not just the name, but I also have to tell where this file is. So that is exactly what I'm going to do over here, since it's in my day 13 directory. So I'm going to write day 13 over here, and hopefully now it will not give me an error. And yes, it has successfully ran. I can see that it has successfully detected the faces on my image, and it is pretty cool as well. Now that we have written the code on how to detect the faces on an image, we will see how we can modify the same code to detect the faces on a webcam. So I am going to comment out this code for now, and this as well, and I'm going to start writing my new code over here, but this time it's going to be for a webcam. So the first thing that I have to do is to read my webcam, so that is exactly what I'm going to do. So I'm going to use my video capture function, pass 0 over here, then while true loop, because it's gonna, there's no end to a webcam, right? And it's gonna read true values, read and a frame, and I'm gonna use webcam dot read to read the frame. If it has successfully read the frame, the value of it will be true, otherwise it will be false. Then I will repeat the processes that I have been doing earlier. I will first convert my frame. I will first convert my frame into a grayscale image. So that is exactly what I'm going to do here. I'm going to paste this line, but instead of image, I'm going to pass my frame over here. The next thing that I have to do is to detect the faces, right? So I'm going to copy this line from here, and I'm going to paste that over here. So this line will be exactly the same because this time I'm passing my grayscale image over here. The next thing that I have to do is to write this for loop. So let's do that as well. And then I'm going to draw the bounding box on my frame, okay? Not on the image, but on the frame. And the last step is obviously to visualize my frame. So that is exactly what I'm going to do here. I am going to copy this line, okay? But instead of visualizing the image, I'm going to visualize the frame, and I can call it as the frame or webcam as well. Totally up to me. And then I have to write the logic to close that webcam. So I will do that. And yeah, that is all. You have successfully converted your code from detecting the faces on an image to detecting the faces in real time using a webcam. Now let's run it and see if it's working properly. So yes, it is working properly. It is detecting the faces on my image just like it did in the start. So you guys have successfully created your face detector, but the thing about this tutorial is that you can use it for detecting any type of thing on the face. Now that you know to how to use a pre-trained model, you can use it to train any one of these models that you have over here. The link of this, I will share this in the description of my video, so you can try testing it out for detecting the smile, maybe to detect the profile face, the lower body, or anything like that. So that was all for today. I hope you guys enjoyed the video, and stay tuned for the next one. Bye bye.